Kia ora koutou. This is a remake of a video that I posted briefly a couple of days ago, and then Cohen sent me an email saying that there was a far, far better way to do it than the long, complicated way that I did. So then I was embarrassed, and so I deleted the first video because I felt really stupid, and now I'm going to make a second video showing you the easy way that I really should have seen the first time round. So if that all sounds exciting, stay tuned. This is similar to question 8 in exercise 3C of the A-level textbook, but because of copyright, I've changed around the numbers. I don't think that they can copyright an identity, so I've kept the identity exactly the same. So the first thing we have to do is to show that this is a true statement. And then, given that tan of this is equal to this, we have to solve this equation here. Now, this is the bit where I just went so massively over the top with how I did it that I'm going to redo it. And then I'm going to show you the first way that I did. Okay, so let's look at this first identity proof, which is a nice example. Remember that we know that tan of A plus B is equal to tan A plus tan of B over 1 minus tan A tan B. So we can apply that pretty much directly into what we've got here. And when we do any kind of identity work, we start by saying, what have we got on one side? Now, that side will usually be the left-hand side. On the left-hand side, we've got tan of pi on 4 plus some angle theta times tan of pi on 4 minus theta. And we're doing a proof, so we need to show all of the little steps. What we want to end up with is something that equals 1, which is my right-hand side. So in here, that first factor will give me tan of pi on 4 plus tan of theta over 1 minus tan pi on 4 tan of theta. And I can hear some of you, one particular, screaming, but we know that tan pi on 4 is 1, so can we not just get on with it? Well, the answer is no, you're not just going to get on with it because you're doing a proof. So the goal here is to show an intelligent reader what are all the little steps that I did. So then in the next bit, we're going to go tan of pi on 4 minus tan theta divided by 1 plus tan pi on 4 times tan theta. That's because the matching tan compound angle goes like this. So we've got tan of A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Couple of things on that. Yes, as I've said 1,000 times by now, they're on the formula sheet, but also you can easily prove this second one from the first one if you just work it as tan of A plus negative B. And remember that tan is an odd function. So tan of negative B is equal to negative tan B. And if you use that fact, then this identity here falls out really easily. Anyway, getting back to what we're trying to prove, we've got to here, and tan of pi on 4 is equal to 1, and that's coming from my special triangle. So here's pi on 4. So now we can write this as 1 plus tan theta over 1 minus tan theta times 1 minus tan theta over 1 plus tan theta. So look, how nice is that? And everything simplifies. Whoosh, whoosh, whoosh. And that equals 1, which is the right-hand side as required. Okay, so the next part of the question is to solve, if we're told that this is true, solve this. Don't use your calculator, and you can assume that theta is in the first quadrant. So the way that I did this first is I did some stuff with some graphs, and I used this identity up here. But here's the other thing that I know. Theta is between 0 and 90 degrees. That means that I'm working with a baby right-angled triangle. I'll try and draw that properly, since this is meant to be a video by a maths teacher. So we better draw some nice straight lines. Now I could even draw this with an 18-degree angle if I felt like it. Let's see what we've got. Let's see, have I got it right? Not quite. We'll go a wee bit higher up here. You can see I'm just about giving you the answer as I do it. There. So let's draw our triangle like this. Okay, this is wildly now not to scale either. What do I know? Look, I've got tan of 18.4 degrees is 1/3. So we're just going to use some year 10 trig. The opposite side here is 1. The adjacent side is 3. So this angle is 18.4 degrees. We're told, and that's a right angle, we are told to solve the problem that tan of theta is equal to 3. 3 is the same as 3 over 1. This is the opposite. This is the adjacent. So this is theta here. So theta is equal to 90 minus 18.4 degrees, which is 72.6 degrees. Okay, so that's the embarrassing thing that Cohen emailed me and said, Miss, wouldn't it actually be fine to do it this way? Yes, of course it would. And this is a much, much better way to do it than what I did. So now I'm going to show you what I did in the first video, and maybe some of you will still be watching. The only benefit to looking at it this stupid long way is that I think it does reinforce some things about trig graphs. And what we're told here is that we've got, if we take the tan, working now with degrees, not with radians, if we've got tan of 45 plus some number times tan of 45 degrees minus a number, when we times those two things together, we get 1. And you can see why in the first quadrant from this picture down here, right? One trig ratio is going to be 1/3, and the other one is going to be, so this is going to be 1 over 3, and the other one is going to be 3 over 1. So putting that into some algebraic identity says that when we do this times this, we end up with 1. If we're looking at it here where we've got tan of 18.4 degrees, we can treat that as this factor, and then we can work this out, right? So how far is 18.4 from 45? 45 minus 18.4 degrees is a gap of, what have I got, 26.6 degrees. So here we've got 45 and we've taken off 26.6. And so for the other one, we're going to have 45 and we're going to add on 26.6. So we get 45 plus 26.6, which is equal to 71.6. Yeah, and down here, I'm sure someone by now will have left me a comment that I made a mistake. That should definitely be 71.6, not 72.6. Okay, so looking at that graphically, it looks like this. This is my tan graph, and you can think of the 45 degree mark on here, which is here, as kind of like your balancing point for reciprocal things. So in this case, we've got 1/3 here, and we've got 1/3 here, and we've got 3 up here. On a different graph, this is the graph that I did for the first video, which is still sitting here in my memory. You can see what's going on here, right? So we've got the 45 degrees, and we can add in one direction and subtract in the other direction. But there's no reason to do that with this question, right? So the fast way of just going straight to that right angle triangle is definitely the best way here. So Andy, there's the video that you wanted. I'm hoping that made sense. Send me an email if you have got any questions on it, and let me know if there's anything else you want YouTubed in the next few days.